student, welcome to my channel. So in this slot, we're going to discuss a few essay questions from chapter 1, right? Chapter 1, redox equilibrium. So we move on to the first question, all right? First will be electroplating of iron spoon or iron key using suitable electrolyte. Under redox reaction, rusting of iron nail when come in contact with different metal, electron transfer at distant or U-tube cell, and the most important will be to investigate the effects of concentration of ion selectively chosen to be discharged at anode during electrolysis process. These are the most important essay questions. So we move on to the short essay question. Before we move on to the short essay question, please remember the definition for redox reaction. Student must remember the definition for redox. So I take OX stand for oxidation. All right, OX stand for oxidation and RED stand for reduction. When these two processes occur simultaneously, the reaction called redox reaction. So the answer, chemical reaction, where involving oxidation and reduction occur simultaneously. And please remember point number two, all the process involved during oxidation and reduction, during chemical reaction, the reactants A plus B. All right, so this redox reaction involved with reactant. If let's say one of the reactant undergo oxidation, so that means we need to put oxidation. So I put here oxidation, I put SMI. All right, so oxidation means gain oxygen. I don't like E, so I put here loses hydrogen, loses electron, increase in oxidation number. All right, so and remember oxidation, the reactant that undergo oxidation will act as reducing agent. So reduction is given in the module. Please go through. All right. Please memorize all the oxidizing agent and reducing agent. Please check. Please remember oxidizing agent undergo reduction, and reducing agent undergo oxidation. All right, so example, acidify potassium manganate 7. All right, acidify potassium dichromate 6, chlorine solution, bromine solution. All right, iron 3 nitrate solution, or any solution that contains iron 3 ion, and the this one, the acidify hydrogen peroxide solution. All right, reducing agent, potassium iodide solution, iron 2 sulfate solution, potassium chloride solution, reactive metal like magnesium and zinc, sulfur dioxide. All the F equation I already discussed in previous video. Please check all the video. So we go for non-redox reaction. Please remember neutralization, precipitation, and one more, thermal decomposition of metal. All right, thermal decomposition of, for example, copper to carbonate heated strongly, we will get metal oxide. The metal is copper, so metal oxide will be copper to oxide plus carbon dioxide. All right, so the answer why this is non-redox reaction, because there is no change in oxidation number. All right, so please remember all these example of short essay question. All right, we move on to the another short essay question. All these I already discussed. All right, another very important reaction is displacement of metal. All right, so when here they put zinc, strip of magnesium strip, so here copper to sulfate solution, so this is known as a displacement reaction. All right, so if they ask what is mean by displacement reaction, is a chemical reaction where less electropositive metal from its salt solution will be displaced by a more electropositive metal. All right, so we go for chemical equation. So it's given oxidation, more electropositive metal. So please remember more electropositive metal. All right, more electropositive metal like magnesium and zinc, they will undergo oxidation. All right, so they will undergo oxidation. They will act as reducing agent. All right, so I try to do one equation here. So when magnesium react with silver nitrate solution, so how to do the equation? So we take out the ion Mg2 positive, we take out the silver ion, we take out the nitrate ion. During chemical reaction, magnesium is more electropositive, so what will happen? So displacement will occur. So magnesium NO3, so I take the 2, I put here. All right, so when we put like this, so please remember to open bracket and close bracket. All right, and erase the charge, then put here. And next step, balance the equation. How to balance the equation? Nitrate everything 2, so I put 2 in front of nitrate. All right, then check the silver 2. So this is the chemical equation. Please remember observation. So we try to name the color of the solid deposited, and please remember all solid is a gray color solid, except copper which is brown. All right, so except copper which is brown. So please remember all this and try to do the ionic equation. So before I do ionic equation, I try to do half equation. So I erase this one. We try to do half equation. More electropositive metal, so here this is more electropositive metal, will undergo oxidation. So magnesium arrow, it will loses electron and form magnesium 2 ion. This electron will be gained by someone here. So I take silver ion, nitrate ion. Electron negatively charged, negative repel. Negative will be attracted by cation. So please remember, so reduction will be silver ion. Silver ion gain 1 electron and form silver atom. So this is the half equation that student should write. And how to do the ionic equation, please check this one. I already discussed in previous video. When one capital, one small, so this exists as atom. When one capital, one metal, non-metal, and this is soluble, so this is known exists as ion. All right, so this also ion. This is atom. All right, so we list out all the particles that present here. So magnesium exists as atom. So we have silver ion, nitrate ion. All right, so here we have magnesium ion and we have nitrate ion and silver atom. Remove the spectator ion. So here the spectator ion will be nitrate ion. So I remove all the nitrate ion. All right, so here, so how to do ionic equation? All right, I try to do ionic equation. Magnesium, I take magnesium. All right, react with silver ion. All right, so I get magnesium ion plus I got silver atom here. Next, balance the equation. So check here 2. So I put 2 here, 2 here. So please check 2 here. So this is the ionic equation. And try to check for this question. Right, so all the ionic equation, half equation is given. So please check the observation is given. Proof this reaction is redox in terms change in oxidation number. So observation, brown solid deposited, blue color solution, copper 2 sulfate. Please remember it's a blue color solution. The blue color solution will turns to colorless. So here already put. All right, so check the oxidation number. Oxidation number of zinc. So oxidation number of zinc is 0. So here it increases to positive 2. So how to answer explanation? Zinc undergo oxidation because its oxidation number increases from 0 to positive 2. Copper 2 ion. So please check the oxidation number of copper 2 ion positive 2. When go here it turn to 0. So it decreases in oxidation number. Here increases in oxidation number. So how to answer this one? Copper 2 ions undergo reduction because its oxidation number decreases from positive 2 to 0. When oxidation and reduction process occurs simultaneously, the reaction is called redox. So please remember to put oxidizing agent and reducing agent. So how to find the oxidizing agent? Just write redox. Cancel the OX, cancel the OX. Which reactant undergo reductions? Which reactant undergo reduction? Copper 2 ion. So please name the ion copper 2 ion. Alright, so here I write down redox. I cancel RED, cancel RED. Which reactant undergo oxidation? That will be zinc. Please mention zinc atoms. So this short essay question is very famous question. So please memorize, please do more question. Please remember how to find the oxidation number of elements that present in a compound. I already discussed in previous video. All right, so how to answer here? So we try to do one question here. Look at this question. All right, so here they given two compound. Okay, they want state the oxidation number of magnesium and copper. So how to find the number one? So I put here oxidation number of magnesium. So here I put magnesium oxide. When we see here sum up should be 0. All right, so I don't know the oxidation number of magnesium, so I make it X plus oxidation number of oxide ion. So here, so total will be 0. So X plus with negative 2. We take the negative 2, 0. So X minus 2 will be 0. So X will be positive 2. Then they want the, alright, so we already find the oxidation number of magnesium oxide. So I put here oxidation number of magnesium. Magnesium in magnesium. Magnesium oxide is positive 2. Alright, please remember to put positive 2. So we copper to oxide. So this one Cu2O. When we sum up, we want to find the oxidation number of copper in this compound. So we have copper 2. I don't know the oxidation number. We will represent with X symbol plus with oxide ion. When sum up should get 0. So 2X plus with minus 2. So 0. So 2x minus 2, 0. So 2x, when we bring here this one here positive 2, x will be positive 1. Alright, so we name the oxidation number. So oxidation number of copper. Copper in Cu2O is positive 1. Alright, we try to do this second question. So second question, state the name of the compound. They want the name of this one. So number 1 will be MgO, will be magnesium oxide. Alright, so Cu2O will be copper. Check the oxidation number is positive 1. So we put your copper bracket oxidation number 1 oxide. So this is the answer. Please go through this question. Alright, this type of question. Alright, so we move on to the next question. Next question, displacement of halogen. Very important, displacement of halogen. All right, so here we have chlorine. Please put chlorine solution, the formula Cl2. All right, potassium iodide solution, Ki solution. And please remember all group 17 elements. They exist as diatomic molecules. So when chlorine molecule, we have to write as Cl2, Br2, I2. The formula should be like this. And please remember when group 17, the reactivity of metals, so chlorine, bromine, bromide, iodide. When going down, the reactivity will be decreases. So displacement of halogen will occur when particles, so like chlorine molecule, react with potassium iodide solution. So we take out the ion, chloride ion. We take out the potassium ion. Potassium ion act as spectator ion. Alright, so we take out the iodide ion. So which one is more reactive? Okay, chloride. So chloride replacement will occur. Displacement will occur. So here we will get KCl. When iodide ion single, we put another iodide ion, so we make it iodine molecule. So we put iodine molecule here. All right, so next how to balance the equation. Just balance iodide 2. So I put iodide 2, potassium 2, potassium 2. All right, so this is the chemical equation that students should write. All right, so how to do half equation for oxidation, how to do half equation for reduction. Please remember this chlorine molecule act as oxidizing agent. Oxidizing agent undergo reduction. Reduction means gain electron. If chlorine molecule act as oxidizing agent, therefore potassium iodide solution will act as reducing agent. So here potassium iodide is a soluble salt solution, so we have made up of ion. Take out the potassium ion and iodide ion. This potassium ion already achieved stable octet electron arrangement. Therefore, it acts as observation ion or spectator ion. Remove this one. Take the iodide ion, put here. Iodide ion must put 2 in front here, arrow. It will donate 2 electron. Alright, so it form iodine molecule. Take the chlorine molecule, will undergo oxidation. Take the 2, put here 2 electron. Alright, take the 2, put here 2 chloride ion. So this is the half equation that student should write. Alright, how to do ionic equation. So I try to do ionic equation here. Ionic equation, so we check the equation, the chemical equation given here. Alright, so we try to identify the particles. This is molecule, this is ion. When one capital or one metal, non-metal ion, soluble ion. So this is ion. Alright, so this is molecule. Alright, molecule. So we list out all the particles present in reactant. So chlorine molecule, potassium ion and iodide ion. So here we have potassium ion and chloride ion. So and we have iodine molecule. Remove the spectator ion, which is potassium ion. Alright, so I take the chlorine molecule, put here, and iodide ion I put here. So we have 2 iodide ions, so I put 2 here. Alright, so we have chloride ion, so I put here. We have 2 chloride ions, so I put here. Then iodine molecule. So this will be the ionic equation. So please practice and please go through do more question. Very important essay question for this year SPM. So we check here. So chlorine solution is a greenish yellow color. Please remember, it's a greenish yellow color solution. All right, potassium iodide solution, potassium ion and iodide ion. All this is colorless ion. So therefore the solution is colorless. Alright, so the solution will be colorless. Write down the chemical equation given here. Alright, write down the state the oxidizing agent and reducing agent. So oxidizing agent will be chlorine molecules and iodide ion in potassium iodide solution act as reducing agent. Half equation, please remember. Okay, oxidation and reduction. Ionic equation, please remember. Okay, observation, so we take the observation. The main solution here will be potassium iodide. So the color of the potassium iodide is a colorless solution. So in this reaction we will get potassium iodide react with chlorine, so we will get KCl plus iodine molecule. So balance, put 2 here, 2 here. All right, so this solution, so here we have colorless solution will turn into brown color, or student can put yellow color. Alright, so here the color solution turns into brown. Alright, so next will be state the oxidation number of change in oxidation number of chlorine oxidation number of chlorine in solution or chlorine molecule. Please remember when they put change from what oxidation number to what oxidation number. So I put here decreases from 0 to -1. Check here 0, here -1. Alright, so next one, change in the oxidation number of potassium iodide solution, or here they want the iodide ion. Check the half equation for oxidation, -1 to 0, molecule 0. So increases from -1 to 0. Alright, so already given. Please remember when we add 1, 1, 1 trichloroethane. ethane solution. So what will happen? This is ethane. So what will happen? Two layer of the solution will form. Please remember, two layer of solution will form when we have iodine. So put here BP. The above layer which is less denser will be brown, and the bottom layer which is more denser will be purple color. All right, so please remember brown and purple. All right, so answer is given here. Please remember this short question. All right, student, please check question number 10. Already discussed in previous video what is mean by electrolyte. Electrolyte is a substance that can conduct electricity in molten and liquid state and can undergo chemical changes. Please check all these. All right, now we move on to the molten lead to bromide. So this process is known as electrolysis process. I already discussed in the previous question, previous video. Please check. So electrical energy converted into chemical energy. Please remember, anode will be positive terminal. It undergo oxidation process. Cathode will be negative terminal. It undergo reduction process. All right, so in molten, please remember the formula of ion will be lead 2 ion and bromide ion. So we write down the 2 ion. So all the answer, please go through. I already discussed in the previous video. Please check this question. Now we try to read this question. A student conducted an experiment to determine a bulb or light bulb using two substance R and L. So here they use molten. So we have lead 2 ion and bromide ion, and this lead 2 bromide, please remember, is made up of ionic compound, and the particles that present in ionic compound, please remember ion. So in molten state, the electrostatic attraction forces has been overcome, and this ion able to move freely and must put this one conduct electricity. Therefore, the bulb is lights up. All right, so in solid state, the lead 2 ion and bromide ion unable to move freely because the ions are held together by stronger electrostatic force. So here they cannot move freely. Therefore, they cannot conduct electricity. So how to answer this question? So we try to do analysis of each substance used as electrolyte, then state which substance can produce a light bulb. All right, so I go for first point. All right, so lead to bromide made up of ionic compound and exist as ions. So I do in substance R. All right, so here I put here substance R, or we can put lead to bromide in molten state. So I put double dot here. So the lead 2 ions and the bromide ions able to move freely because the electrostatic attraction forces have been overcome. All right, so next point. All right, thus lead to bromide in molten state can conduct electricity. Therefore the bulb lights up. All right, so these are the points that student must put in the exam. So I put here exists as ion, lead to bromide in molten state, the lead to ion or bromide ion, or we can put the ions able to move freely, all right, because the electrostatic forces have been overcome. And please make sure put conduct electricity. All right, so don't put carries electricity, all that. All right, so student must put conduct electricity. So we go for substance L. All right, substance L. So we put here solid lead to bromide. So I try to answer this one. So solid lead to bromide. So here we have lead 2 ions and bromide ions cannot move freely. All right, why? Because, all right, so we write down because the the ions are attracted by stronger electrostatic attraction forces. All right, so next point we go for therefore solid lead to bromide all right, cannot. So we put cannot conduct electricity. electricity. We put here thus the bulb do not lights up. So these are the points that student must write in the exam. All right, so we move on to the next question. All right, please check the industrial application of electrolysis process. So I go for this one. So this is known as industrial application. All right, industrial application of electrolysis process. We have three industrial application. So number one, in the extraction of metal from its ore. So please remember PEE. All right, PEE. All right, number one is purification. Number two is electroplating. Number three is extraction. So this is known as extraction of metal from its ore. I already discussed this question in previous video. Please check and please go through. All right, this question also I already discussed in the previous video. Please check and please go through. All right, so this is involved with factor 1. What is factor 1? So here the factor is given in the module. Please check. So the factor 1 standard electropotential potential value, factor 2 is concentration, factor 3 is a type of electrode. So this is factor 1, all right, versus factor 2, which is concentration. So yeah, all right, our next one, factor 1. So this will be factor 1. All right, factor 1 versus factor 3. So this will be factor 3, which I already discussed in previous video also. Please go through all this. All right, so we move on to the next question. All right, so this is U-tube cell electron transfer and distance. Very important. Student must practice how to draw the apparatus setup, everything. So here in this apparatus setup, please put wooden block. All right, so wooden block, and this one must clamp by using retort stand. All right, so in this electron transfer at distance is example of chemical cell. So here anode will be negative terminal, cathode will be positive terminal. All right, so we have two agents, so circle these two electrolyte. All right, so we have one more solution here. So this dilute sulfuric acid act as salt bridge. It will allow the movement of ion in order to complete the circuit, and the chemical energy change will be chemical energy converted into electrical energy. So must remember, and please remember oxidizing agent and reducing agent. So under here, so we try to circle this one. So this will be under oxidizing agent. Oxidizing agent undergo reduction. Reduction will be placed at cathode. Cathode will be positive terminal. So this is positive terminal. So this will be negative terminal. So this is known as reducing agent. Potassium iodide solution, please remember, is a colorless solution. Lead iron 3 nitrate, please remember, is a brown color solution. All right, so when reducing agent undergo oxidation. All right, oxidation. So we have potassium ion and iodide ion. So please remember, potassium ion act as observation ion, already achieve stable octet. So remove this one, take the iodide ion. So we write down half equation and at electrode P. So here this is electrode P. So put 2 here, make it iodine molecule plus 2 electron. Colorless solution turns into brown color or yellow color. Alright, so potassium iodide, please remember, is a colorless solution. Okay, so and here, so we can see colorless solution turns into brown color. All right, so we move on to the next half equation. So here, please remember, this is known as oxidizing agent. So we have Fe3 positive and nitrate ion. Please remove the nitrate ion, take the iron 3 ion. So this will act as undergo reduction. So iron 3 ion gain 1 electron and form iron 2 ion. All right, so answer, brown color solution will turn into green color. Please remember the test to confirm the presence of iron 2 ion. So we add few drops of potassium hexacyanoferrate 3 solution. The green color solution will turn to blue black, confirm the presence. Alright, so here we have iodine molecule. Please remember how to test iodine molecule. We can use two tests. One is 1,1-trichloroethane, or one more we can add starch solution. Alright, so please remember this question. Look at this essay question. So electron transfer at distance. So this one can come out in section C. Section C, question number 11. Alright, so look at the question. Okay, describe electron transfer at distance, include label, diagram, procedure, half equation for oxidation, half equation for reduction, take the movement of electron, okay, electron in the circuit. So I try to draw like this. All right, so we try to draw like this. So this is the drawing that student can use. I use potassium iodide solution, or sometime we can use iron 2 sulfate solution. All right, so iron 2 sulfate solution. All right, so please remember, all these solution act as reducing. reducing agent. It will undergo oxidation. All right. So if potassium iodide solution, please remember take the iodide ion arrow iodine plus 2 electron. If iron 2 sulfate solution, take the iron 2 ion arrow, change it to iron 3 ion. All right. Donate 1 electron or release 1 electron. So here green color solution will turn to brown color. Alright, so this is the half equation if any of this reactant is used. Alright, so here please put sulfuric acid. So here we can put bromine solution or acidify potassium manganate 7 or acidify potassium dichromate 6. Alright, so or chlorine solution. All this is known as oxidizing agent. Please remember this bromine solution act as oxidizing. Alright, we try to check the procedure here. Alright, so first point, pour dilute sulfuric acid into U-tube cell until 1/3 full. Alright, so then we use the pour bromine solution into another end of test U-tube cell. So I put here another end. So at this end we pour bromine solution, and next one pour potassium iodide solution into other end of the test tube. Please put this word carefully. Alright, so please make sure to put the word carefully. Alright, next one, connect the two carbon electrodes with voltmeter or galvanometer by using connecting wire. Okay, immerse or dip the two carbon electrode in at the two solution at the end of U-tube cell. Alright, observe and record the changes that occur at electrode P or electrode Q. So label here electrode P, electrode Q. So next we try to do observation. So observation, if I use Ki solution, colorless solution turns yellow or brown color. Alright, so here bromine solution, brown color turns colorless. Alright, so here iron 2 sulfate solution, green color solution turns brown. Alright, so how to do half equation given? How to do half equation if let's say iron 2 sulfate is used is given, bromine solution, how to do half equation is given. Please look at this question. This question, what is mean by redox reaction? So student must know how to answer the definition for redox reaction. So redox reaction is a chemical reaction where oxidation and reduction occur simultaneously. Alright, so we already answered the first question. So now we try to do read the second question. So we read the second question. Draw one label diagram to show the apparatus setup to conduct the experiment. Alright, the diagram must include apparatus material given in the diagram. So in your diagram, draw an arrow to show the direction of electron flow. Write the half equation for oxidation and reduction. So here U-tube cell, connecting wire, galvanometer. Alright, so carbon electrode, bromine solution, alright, iodine solution, potassium iodide solution, and sulfuric acid is given. So we try to draw the wooden block here. Alright, we try to draw the wooden block here. So I try to draw U-tube cell. Alright, so after that I pour sulfuric acid here. Alright, so I put carbon electrode. We need to dip the carbon electrode is here. Alright, so I erase this one. So the carbon electrode is connected to check the apparatus given in the question. So galvanometer. So I put here galvanometer. So we try to draw here. Alright, so next one. Alright, so we need to use the stopper. So please remember stopper draw like this. Alright, so next we need to add the solution. So we have bromine solution, potassium iodide solution. So potassium iodide solution. So here I put potassium iodide solution. So we add potassium iodide solution. Alright, so here we need to add bromine solution. Bromine solution and dilute sulfuric acid will be at the bottom here. Alright, so we try to put draw the symbol of retort stand here. Alright, this is the one we have to draw. So we have connecting wire U-tube cell. So we try to read the question again. One label diagram. So we have to label. So this is known as connecting wire. So we label this is known as carbon electrode, and we label this one is galvanometer. All right, so we have 1, 2, 3, 4, 5. All right, so these are the drawing that students should draw. All right, next we try to write down the half equation. Show the direction of electron flow. Electron flow, so please remember potassium iodide solution. All right, so will act as a reducing agent. It will undergo oxidation. Oxidation will occur at negative terminal. So this is negative terminal, this will be positive terminal. So we take the flow of electron from negative terminal to the positive terminal. All right, so this one settled. So next one, half equation. We try to do half equation at positive terminal and negative terminal. So I write down here negative terminal. Negative terminal will be N naught. So negative terminal undergo oxidation. So we take the potassium iodide solution. We have potassium iodide ion. So potassium ion already achieves stable octet electron arrangement. Therefore, it will act as observation ion. So please take iodide ion, put 2 here, make it iodine molecule plus 2 electron. All right, so we go for positive terminal. All right, the positive terminal will act as cathode. All right, so positive terminal will act as cathode. So here positive terminal, so we have bromine solution. Please remember bromine solution Br2, not Br. And this bromine solution act as oxidizing agent. So I take the bromine solution plus take the 2, put here 2 electron, take the 2, put here 2 bromine ion. So this is the half equation. All right, so next one, if they ask what is the oxidizing agent and reducing agent. So how to identify the oxidizing agent? Must choose the reactant. So here we have reactant, this 2 is the reactant. So between iodide ion or bromine ion, how to find the answer? So write down redox. Cancel OX, cancel OX. Which one undergo reduction? So reduction will be bromine. So put here bromine molecules. All right. So reducing agent will be iodide ion. So I put here iodide ion. So these are the answer that students to write in the exam. So please remember this one. All right, this essay question is very important also. So we move on to the next question. Please check question number 22. This one also I already discussed. Simple voltaic cell. So we have zinc plate here, copper plate here. Please check the E naught value of zinc. They give it to here is negative symbol. So negative symbol, take the negative, put here, positive, put here. Electron flow from negative terminal to positive terminal. So N naught will be, remember N naught negative terminal. So choose the electrode. So I choose the electrode. So this electrode is made up of zinc atom. So the half equation zinc becomes zinc 2 positive by losing 2 electron. It will ionize and form zinc atom, ionize to form zinc ion. All right, so the electron already flow here. Please don't choose the electrode at the cathode. So positive terminal, choose the electrolyte. Electrolyte is sulfuric acid, so it's contain hydrogen ion and sulfate ion. Put the electron negatively charged. So negative repel, choose the hydrogen ion. So at cathode or positive terminal, hydrogen ion must put 2 electron become hydrogen molecule. So these are the observation that student must write. All these I already discussed in the previous question, and this is complex voltaic cell with porous spot and also salt bridge. Please remember the content of salt bridge. So please put here the content of salt bridge. Right, so we take the content of salt bridge, sodium nitrate solution or potassium nitrate solution. Please remember these two solution. All right, please go through the video in previous video. All right, so we check this question. Try to read this essay question. All right, so in this question diagram 10.2a is electrolysis process. So I put here this is electrolysis process where electrical energy converted into chemical energy. So anode here will act as positive terminal, it will undergo oxidation. Cathode will act as negative terminal, undergo reduction. So we check here copper 2 sulfate solution. So we have copper 2 sulfate solution. Please remember solution got 4 ions. So list out all the ion. So here copper 2 ion, sulfate ion. Take another 2 ion from water molecule. It will hydrolyze or ionize to produce hydrogen ion and hydroxide ion. All right, write down the table like this. Anode positive terminal, cathode will be negative terminal. All right, move the ion according to the anode and cathode. Please remember anode is positive terminal, it attract all the N ion. So I put here hydroxide ion is here, sulfate ion is here. All right, cathode it will attract hydrogen ion and copper 2 ion. Please remember anode E naught value lower, less positive or more negative will be chosen. All right, cathode E naught value higher will be chosen. All right, so E naught value of this one is 0.00 volt. This one will be positive 0.34. So therefore copper 2 ion will be chosen at cathode. All right, so E naught value of hydrogen hydroxide ion. E naught value of hydroxide ion will be positive 0.40 volt. All right, so E naught value of sulfate ion will be positive 2.01. All right, so which one is less positive? So hydroxide ion will be chosen. So for diagram 10.2a, so the anode how to do half equation. So hydroxide ion, please remember 4 orang utan. Alright, makan 2 biji orange, minum 2 gelas air. Alright, makan 4 biji apple. Copper 2 ion undergo reduction. So at cathode, please remember copper 2 ion gain 2 electron and form copper atom. So these are the process that will occur at diagram 10.2. So we go for this one. So we go for check the next one. Alright, so magnesium and copper electrode is used. Two different metal with different greater different potential value is used as a electrode. So here we use voltmeter, so therefore this is known as voltaic cell. Voltaic cell chemical energy changes into electrical energy. Alright, so anode will act as negative terminal. Please choose more electropositive metal. More electropositive metal, magnesium and copper. Please remember what is mean by ANODE, the metal that above. So I put here above. Alright, so it will act as negative terminal, so undergo oxidation. Oxidation means donate valence electron. All right, so donate valence electron. So anode will be magnesium, cathode will be copper. So take the flow of electron from negative to the positive. Anode, the electrode, please take. So anode negative terminal, please take the rod is made up of magnesium atom. So I take the magnesium, it will ionize to produce magnesium 2 positive, losing 2 electron, undergo oxidation. Cathode. Alright, so cathode, don't choose the electrode, choose the solution. So at the cathode, please choose the solution. The copper to sodium nitrate solution, sodium chloride solution. So we have sodium ion, chloride ion solution, got 4 ion, hydrogen ion and hydroxide ion. Cathode got electron. Okay, accept electron. So electron negatively charged. All right, so negative repel through these 2 ion. So which ion will be chosen? So please remember hydrogen ion. Copper 2 as a sodium ion already achieved stable octet electron arrangement. So I take the hydrogen ion, 2 hydrogen ion, gain 2 electron and form hydrogen gas. All right, we move on to the next question. How to answer the question? We check the question. All right, we try to read the question. So state the differences between diagram 10.a, 10a, 10b based on the following information. They want the formula of the ions present in each electrolyte. All right, so state ions. All right, they want the observation at positive terminal. So they want the give reason for the observation of equation at each negative terminal and the advantage of this cell. So diagram 10.2a is electrolysis, so electrolytic cell. So I put here electrolytic cell. Alright, so diagram 10.2b is voltaic cell. So I put here voltaic cell. So here all the ions that present in the electrolyte. So we check the electrolyte use is copper 2 sulfate solution. All the ions, so here copper 2 ions. So I list out, try to name the ions. So I put here copper 2 ions. So I put symbols U2 positive. Next ion will be sulfate ion. So copper 2 ions. So I put here next ion will be sulfate ions. So SO4 2 negative. Next ion will be hydrogen ion. So I put here H positive and hydroxide ion, so OH negative. All right, so this is the solution that used in electrolyte that used in diagram 10.2. All right, I move on to the diagram 10.2b. 10.2b, we check the solution. Electrolyte used is sodium chloride solution. So it contains 4 ions. So I write down here first ion. It contains sodium chloride solution. So first point will be sodium ions, Na positive. Second ion will be chloride ions, so Cl negative. All right, so then hydrogen ions, H positive, and next one will be hydroxide ion. All right, hydroxide ion. So these are the ions that we should write in the first requirement of the question. So I'll go for next one, observation at negative positive terminal. Please remember this is known as electrolytic cell. So electrolytic cell, the positive terminal will be anode. Anode will be positive terminal. It will undergo oxidation. So anode, the ions that attracted to anode will be hydroxide ion and sulfate ion, N ion. So which ion will be chosen? Hydroxide ion, because the E naught value of hydroxide ion is less positive than the E naught value of sulfate ion. So when hydroxide ion chosen, so answer observation will be colorless. So I put here colorless gas, gas bubbles, bubbles, okay, is released, 1 mark. All right, so next point, give the reason. Why is the reason why we choose hydroxide ion? Because the E naught value of hydroxide ion is less positive than the E naught value of sulfate ion. All right, so next point, thus hydroxide ion selectively chosen to be discharged or to be oxidized, okay, oxidized or discharged at positive terminal. So this is the answer. All right, next one, half equation at negative terminal. So this is positive terminal, so here negative terminal. So they ask negative terminal, the negative terminal will be cathode will be negative terminal. It will undergo reduction. We have two ion, hydrogen ion and copper 2 ion. Please remember, our negative terminal, choose the E naught value higher. So the E naught value higher, so this is 0.00 and this is positive 0.34, so therefore copper 2 ion will be chosen. So half equation at negative terminal, copper 2 ion gain 2 electron and form copper atom. So we erase all this. All right, so we move on to the advantage of this electrolytic cell. So it's used to convert electrical energy changes into chemical. All right, so chemical energy. So these are the points that students should write for the diagram 10.28. All right, I go for diagram 10.2b. All right, so we check the observation as positive terminal. So here the positive terminal, so we check the positive terminal. So this is known as positive terminal. All right, this is known as voltaic cell. So remember, anode for voltaic cell will be negative terminal, cathode will be positive terminal. So positive terminal will be cathode. So under cathode, so we have copper electrode. So don't choose the positive terminal copper electrode, choose the solution. The electron is already moved. The solution contains ion. So electron negatively charged particle. So we choose positive ion, which is sodium ion, hydrogen ion attracted to cathode, all right, or positive terminal. So this sodium ion already achieved 2.8 stable octet electron arrangement, therefore choose the hydrogen ion. So observation at cathode, colorless gas bubble is released. All right, so the reason for this one, so the E naught value, so here the E naught value of hydrogen ion, all right, is more positive than the E naught value of sodium ion. So thus we put here, thus hydrogen ion selectively chosen to be discharge at positive terminal. So this is the answer. All right, so next one we go for next one, half equation. So half equation at negative terminal. So please remember, negative terminal for voltaic cell will be anode. All right, so anode is negative terminal. All right, so anode we have magnesium, so we take the magnesium, more electropositive metal. Magnesium become magnesium 2 positive by losing 2 electron. All right, so the advantage for each cell will be your chemical energy changes into electrical energy. So this is the answer that students should write in the exam. All right, so please go through all these, please do more revision. Check question number 24, already discussed in previous video. Please check the answer. All right, now we move on to this one, half cell. So this is known as half cell. So please remember, half cell they will use standard hydrogen electrode. The standard hydrogen electrode value 0.00, and here they use zinc. All right. So when we see here negative symbol, that means the anode will be negative terminal. So we choose the zinc electrode. So zinc arrow undergo oxidation and form zinc ion. So the electron move from the negative terminal. So this will be the negative terminal, this will be the positive terminal. The electron will move from negative terminal from zinc electrode to the positive terminal, which is platinum, which coated with platinum for oxide. So the electron will move here. So here we have two molecule particles. So we have hydrogen molecule and hydrogen ion. All right. So we have hydrogen molecule and hydrogen ion. So please remember, electron negatively charged particles. So negative will be attracted by hydrogen ion. So cathode, please put here two hydrogen ion, gain two electron and form hydrogen molecule. This is the half equation given. Please try study the voltmeter reading, and this question also I already discussed in the previous video. And please remember the four standard condition that require to measure the SHE standard electrode potential. So which is concentration 1.0, temperature 25 or 298, pressure 180 m, all right, or 101 kilopascal, and platinum. And please remember, the platinum must coated with platinum for oxide. Why? Because to increase the surface area of platinum to absorb hydrogen gas, so that hydrogen molecule are in closer contact with hydrogen ion in the solution. All right, we try to check this question. Try to read this question. All right, so diagram 10.1 shows the apparatus set up to determine the standard potential value. So here they use SHE. All right, so SHE, please remember, E naught value of hydrogen ion 0.00 volt. All right, so here they use zinc electrode. So the E naught value of zinc ion, please remember, negative 0.76 volt. All right, so anode will be negative terminal, sorry. So anode will be zinc electrode. So choose the zinc electrode, arrow, zinc ion 2 positive, ionize and form zinc 2 ion. Right, so the electron will move from the negative terminal, okay, which is zinc electrode, to the positive terminal, which is platinum electrode. So here we have hydrogen molecule and also hydrogen ion. So we have hydrogen ion and hydrogen molecule. So electron negatively charged particles. So negative will be attracted by attracted to hydrogen ion. So your cathode, which is positive terminal, we take the two hydrogen ion, gain two electron and form hydrogen molecule. So we try to answer this question together. All right, so now explain how the standard electrode potential value of zinc is determined. So how is determined? When we take the zinc electrode, all right, so in the half cell, please remember, in the half cell is connected to the connecting wire is connected to standard hydrogen electrode and also salt bridge, and we dip into a solution that containing zinc 2 positive ion. All right, 2 positive ion with concentration 1.0 mole dm negative 3, potential differences will obtain, and these potential differences of zinc has greater tendency to release electron, and therefore zinc is placed under negative terminal, it undergo oxidation. So SHE is placed under positive terminal. All right, so it undergo reduction. So how to answer this question? The standard electrode potential of E naught of zinc is obtained when a half cell. So we put here when a half cell consisting. So we talk about the electrode consisting of a zinc electrode. Zinc electrode is deep or immersed deep into a solution containing. So we talk about the concentration containing 1.0 mole dm negative 3 of zinc ions. Okay, ion is connected to a standard hydrogen electrode, and please remember to put salt bridge. Okay, salt bridge is very important, so allow the movement of ion in order to complete the circuit. So and a salt bridge. So this is the answer that students should write. All right, so second point that students should write, how we determine the positive terminal and negative terminal is based on the E naught value. So the E naught value of zinc, all right, so remember negative 0.76. So the E naught value of hydrogen ion, please remember 0.00 is not negative, 0.00 volt. All right, so based on this we need to determine the position. All right, so the standard hydrogen potential is 0.00 volt. All right, and the voltmeter reading of of 0.76 volt. This shows what? This shows the electrode potential. Potential shows the electrode potential of zinc. Zinc as a greater tendency to do what? To release electron. To release electron. Compare to what? So I put here compare to the standard hydrogen electrode. All right, so next point that we must put here, so therefore we try to identify the terminal. Okay, thus zinc electrode act as negative terminal. All right, and the platinum electrode, or we can put electrode, or we can put standard hydrogen electrode act as positive terminal. All right, positive terminal. All right, next point that student must write here, the movement of electron. So the electrons move from zinc electrode to the platinum electrode. So please check, the electron will move from the zinc electrode to the platinum electrode. So these are the answer that students should write. So I read again. So I read here the first point, the standard potential electrode of zinc is obtained when a half cell consisting of zinc electrode is dipped into a solution containing 1.0 mole dm -3 of zinc ion solution is connected to a standard hydrogen electrode and a salt bridge. The standard hydrogen potential is 0.00 volt, and the voltmeter reading that shows 0.76 volt, okay, shows the electrode potential of zinc has greater tendency to release electron compared to the standard hydrogen electrode. Thus, zinc electrode act as negative terminal and the standard hydrogen electrode act as positive terminal. The electron move from the zinc electrode to the platinum electrode. Then we check the next requirement of the question. They want the half equation at the negative terminal, half equation at the positive terminal. All right, so I put here half equation at negative terminal. So we put here half equation at negative terminal. So we choose the E naught value. So E naught value of zinc 2 positive is negative 0.76 is more negative. So zinc undergo oxidation. So zinc 2 positive plus 2 electron. We already discussed just now. All right, so next one, half equation at positive terminal. So the positive terminal, so the electron already moved to the positive terminal. So we have two particles here, so we check which particles will accept electron. So we have two particles, so electron negatively charged, so negative will be attracted to the positive, therefore hydrogen ion will undergo reduction at positive terminal. So hydrogen ion gain 2 electron, so must put 2 electron and form hydrogen molecule. So this is the half equation that student should write. All right, next one we try to check. They want the standard electrode potential of zinc half cell. So how to write this one? So I write down here. Write like this. So we take the zinc 2 positive, okay, gain 2 electron, reversible arrow. So we put here zinc. So the E naught value will be negative. The E naught value will be negative 0.76 volt. So this is the answer that students should write for this essay question. Please stay focused, don't give up, and try to do more. Right, now check, please check this question, extraction. So this is known as extraction. All right, extraction of iron from its ore. So this is industrial application. So please remember, all these are the waste gas that produced in this reaction will be carbon dioxide. All right, so the all are iron ore. All right, so this iron ore will be hematite or magnetite. The raw material added is coke stone, used to reduce the iron from its oxide, limestone to remove the impurities such as sand, the iron ore, hematite, and magnetite. So hematite will be Fe2O3, magnetite will be Fe3O4. So this is the formula. So in this reaction, we will use a reduction of iron by carbon and also carbon monoxide. All right, so and this reaction, please remember the zone 1, the reaction that occur at zone 1. So the zone 1 is here, the blast furnace is blow up with hot air, so until the temperature at the bottom reach 2000 degrees Celsius. Then the ox stone will come in contact with oxygen to produce carbon dioxide. So carbon ox stone will contact with hot oxygen to produce carbon dioxide. So the carbon dioxide will expand and will rises up. So the carbon dioxide will expand and will go up and will come in contact with ox stone again, and it will produce carbon monoxide. So here carbon dioxide will come in contact with ox stone, it will produce carbon monoxide, balance the oxygen 2, I put 2 here. All right, so the carbon and carbon monoxide will act as reducing agent. Please remember, it will undergo what reaction? It will undergo oxidation. All right, so in this reaction, please remember the equation, how to do the equation. I try to do for the hematite. So here Fe2O3, so put carbon, react with carbon. So extraction of iron from its ore will occur. Iron will come out and carbon will combine with oxygen to produce carbon dioxide. All right, how to balance this equation? So take 3, put here. All right, take the 3, put here, or take the 3, put here. All right, balance the carbon 3, I put carbon 3. All right, so carbon 3, carbon 3. So the iron will be, so next I balance the oxygen. So oxygen will be 6. So here I put 2 times 3, 6. Iron 2, iron 4, iron 4. All right, so this how we balance this reaction. So here iron 3 oxide. All right, so undergo loses oxygen. So here loses oxygen, it will undergo reduction. All right, carbon gain oxygen. So gain oxygen, it will undergo oxidation. So the function of carbon. All right, so please remember the function of carbon act as reducing agent. At the same time, carbon iron hematite also will undergo reduction, undergo reaction with carbon monoxide. It will produce iron plus carbon dioxide. So how to balance this equation? Take the 3, put here. All right, so next balance the carbon 3. So oxygen 6. So oxygen 3 times 2, 6. Iron will be 6. Iron will be 6. All right, next how to balance the equation. We try to balance the equation. Okay. All right. So once you already get this, we need to balance the equation. How to balance the equation? Take the 3, put here. All right, next balance the carbon 3, oxygen 6. So try to check your oxygen 3 plus 3, 6. So iron will be 2. So iron 2. All right, so that's how we balance the reaction. So here, all right, so the function. So if they ask in the exam, function of carbon monoxide will be act as reducing agent. So please remember all this. All right, so all the equation please study. All right, so the calcium carbonate, please remember calcium carbonate under high temperature, it will decompose to produce calcium oxide plus carbon dioxide. It will produce calcium oxide and carbon dioxide. This calcium oxide will attract all the impurities such as calcium oxide will attract all the impurities such as sand, silicon oxide to form calcium silicate. So it will form Ca. I take the Si, put here O total up, so O will be 3. So this is known as slag, molten slag. So the molten slag will settle down at the bottom here. All right, the bottom here. This molten slag is used doing foundation of a road, manufacture of cement. All right, so the molten iron will settle down more denser. It will settle down at the bottom. So please study this question. All right, so under here next will be rusting. Rusting also is very important. So by using this diagram, I already discussed this question in the previous video. Please check. All right, so a basic condition that needed for the rusting process to occur is oxygen, presence of oxygen and also water. Rusting is a chemical process, and also remember rusting is a slow redox reaction. All right, so the chemical name for rust, please remember, is hydrated iron 3 oxide. All right, the formula Fe2O3.XH2O. The number of water depends on the intensity of the rust form. All right, so the function of iron and oxygen. So oxygen molecule act as oxidizing agent, iron atom act as reducing agent. So how to identify the anode? So the concentration of dissolved oxygen here is lower. Therefore, this will be act as anode. All right, the oxygen can enter easily at the edge of water droplets. So that means the concentration of oxygen at this region is higher. So this region will act as cathode. All right, so anode will undergo oxidation. cathode will undergo reduction. All right, so how to answer region Q? So I take the region Q here. Region Q act as anode. Why? Because this region, in this region, the concentration of dissolved oxygen is lower. The process occur is oxidation. The F equation, the iron atoms that present in the iron block. So here we have lot of atoms. So undergo oxidation. So how to do F equation? Iron atom loses electron and form iron 2 ion. So once they form iron 2 ion, they will diffuse, or they will diffuse in the water droplet. All right. All right, so next point, the iron 2 ion will dissolve in the water droplet. So the electron that donated or loses donated here will move to the edge of the iron block where the concentration of dissolved oxygen is higher. All right, so the electron will flow from the region Q to the region P, the edge of water droplet where there is a plenty of dissolved oxygen. So region P will act as cathode. The process undergo at cathode will be reduction. All right, so the process, why this is act as cathode? So please remember, because this region contains higher concentration of dissolved oxygen. All right, the process occur is reduction. So we need the basic condition, basic condition oxygen. All right, so we need 2 water molecule. All right, so it will gain 4 electron. All right, so it will produce 4 hydroxide ion. 4 hydroxide ion. Please remember, dua biji orange dan dua gelas air, 4 apple dimakan oleh 4 orang utan. Alright, so please remember this one. Alright, so the iron 2 ion. So once hydroxide ion form, it also will dissolve in the water droplet. So when iron 2 ion and hydroxide ion will combine together, they will form insoluble salt. So here it will form green color precipitate. So please remember, it will form green color precipitate. Alright, so this green color precipitate or iron 2 hydroxide will be further oxidized in the presence of oxygen to turn into hydrated iron 3 oxide, and this is known as rust. A brown color solid will form here. So here is a brown color solid. So this is known as rust. Alright, so this reaction, please remember, so we move on to the experiment that related to this experiment, so will be here. Alright, so this experiment can come out in essay question also. So we try to do this question together. So please remember, when iron, so this is act as control. So here iron nail come in contact with magnesium more electropositive, therefore it will undergo oxidation. The magnesium act as sacrificial metal. So oxidation will be undergo by the magnesium atom. So magnesium atom undergo oxidation and form magnesium ion. Therefore, there is no iron 2 ion is absent. In the absence of iron 2 ion, what will happen? The potassium hexacyanoferrate do not form dark blue spot. So here rusting is prevented. Okay, while when iron nail is come in contact with less electropositive metal, so this is known as less electropositive metal. So when iron nail come in contact with copper, so what will happen? This is less electropositive. All right, so rusting will occur at greater speed. So what will happen at anode? Iron will be more electropositive than copper, so iron will undergo oxidation to form iron 2 ion by losing 2 electron. All right, so this electron will be gained at cathode. So which one act as cathode? The copper act as cathode. Alright, copper act as cathode. So here what will happen? Oxygen plus 2 H2O plus 4 electron, they will turn into 4 hydroxide ion. So when we add so here we will add P hexa 3 solution. So here 2, here put hexa 3 solution. P hexa 3 solution means potassium hexacyanoferrate 3 solution. So here we'll get dark blue spot will form a lot. Alright, so for the test tube 2 which has magnesium, here no dark blue spot, so rusting is prevented. Alright, so the pink spot is formed because of the hydroxide ion. Alright, so here a lot, here a little. Why? Because the iron 2 ion will combine with hydroxide ion to form green color precipitate. Alright, so function of potassium hexacyanoferrate to detect the presence of iron 2 ion, phenolphthalein to detect the presence of hydroxide ion, jelly solution to enable us to see the pink coloration or dark blue spot coloration clearly. Alright, so we need to arrange the metal according to ascending order of the electropositivity. Look at the question, arrange the metal according to ascending order of electropositivity. So which metal is more electropositive here? Alright, so magnesium is more electropositive, so we put magnesium on the top. All right, so here the iron will be more electropositive, so I will put iron at the middle. Then the copper is less electropositive here, so the answer magnesium, iron, and copper. All right, so manipulated variable, responding variable, all these please remember. The application I already discussed in previous video, please remember. We move on to the essay question that related to this one. All right, the essay question, please check here. This one can come out in section C, question number 11. All right, so essay experiment can come out in section C. All right, so you are given a iron nail, strip of magnesium, copper. Describe an experiment to investigate the rate of rusting of iron nail. Include material, apparatus, procedure, and observation. So the material, apparatus, and procedure. So we need a test tube here. So we take one is control. So here iron nail. All right, second one, we take the iron nail, we coil with a strip of magnesium. So this is magnesium, this is iron. Okay, and the third test tube, we take the iron nail, coil with a copper strip. So, and we add gelatin solution. So we add gelatin solution, gelatin plus phenolphthalein solution plus PXR 3 solution. Please remember PXR is potassium hexacyanoferrate 3 solution. Alright, so we need test tube, rag, spatula, glass rod. Alright, so we need iron nails. Alright, gelatin solution, potassium hexacyanoferrate 3 solution, phenolphthalein, and sandpaper. Clean 3 iron nails, strip of magnesium and copper using sandpaper. Place the first iron nail into test tube label A. So this is test tube label A. Alright, second one, coil the strip of magnesium and copper into second and third iron nail respectively. Place the second and third iron nail into the test tube label B and C. So this is B and C. Alright, so second one, prepare gelatin solution. How to prepare the gelatin solution? By adding gelatin powder in hot water. Please remember this one. Alright, next we need to add few drops of potassium hexacyanoferrate 3 solution and also phenolphthalein solution. Stir the mixture by using the glass rod. Pour the mixture into gelatin solution into test tube label A, B, and C. Observe and record the changes that occur after 3 days. So what will happen? The first test tube iron nail only. So here iron nail magnesium, here iron nail coil with copper. Intensity of blue spot, here low, here absent, here high. Intensity of pink spot, here low, here high, here low. Alright, so next one, colorless bubbles. So this one no need to write down. So this one no need to write down. Only write this one. These two enough. Alright, so this is the experiment that student need to remember for rusting. Alright, so please go through and please do more revision. Alright, so we move on to the next question. So we try to read these questions together. So diagram 11.1 shows the apparatus setup. So here they use magnesium and silver strip. So here they use voltmeter. So we have salt bridge here. Alright, so this is example of voltaic cell. So please remember chemical energy is converted into electrical energy, and please remember more positive metal. More electropositive metal, alright, will act as anode. Always remember, will act as anode. So anode will be negative terminal, so undergo oxidation process. Cathode will be positive terminal, it will undergo reduction. And the other way, so the E naught value of magnesium is given negative 2.38 volt and the E naught value of silver ion is given, alright, so positive 0.80 volt. So magnesium, the E naught value of magnesium is more negative compared to the E naught value of silver ion. So therefore magnesium act as negative terminal and silver electrode act as positive terminal. Take the flow of electron from negative terminal to the positive terminal. Alright, so what will happen at positive terminal? We try to check the positive terminal and negative terminal. So the negative terminal half equation at negative terminal, which is anode. So we take the electrode, magnesium electrode, arrow become magnesium 2 positive by losing 2 electron. Alright, so the positive terminal, so we check the positive terminal, which is cathode. Alright, so positive terminal, I try to do the so don't take the silver atom electrode. So please take the ion from the silver nitrate solution, contain silver ion and nitrate ion. Solution contain hydrogen ion and hydroxide ion. So electron already at silver electrode. So the electron will be gained by one of these ions. So please remember, electron is negatively charged. Alright, so negative repel. So remove these two ions. So the E naught value, please remember the E naught value of silver ion is positive 0.80 volt. Alright, so and the E naught value of hydrogen ion is 0.00. Alright, please remember cathode, please choose the E naught value ion or more positive. So silver ion will be selectively chosen to be discharged at cathode. Alright, so we put silver ion. undergo reduction, so it will turn into silver atom. All right, so this is the half equation. So we try to answer this question. First question, we try to answer the meaning of redox reaction. Redox reaction, please put chemical reaction where oxidation and reduction occur simultaneously. All right, so this is the answer. So next we try to identify the negative terminal and positive terminal. So I go for question number B1. So I put here negative terminal, which is anode will be magnesium. All right, so I put here magnesium electrode. So the positive terminal will be silver electrode. So I already score 2 marks here. So next they want us to do the ionic equation. So how to do the ionic equation? We summarize and do one equation. Make sure the electron on the right hand side and left hand side is balanced. So here is not balanced. So how to balance? We summarize this one, we times with 2. Alright, so when we times with 2, so here put 2, here put 2. Alright, so we summarize and do one equation. So now what I do, alright, so the electron cancel. So what we have on the left hand side, alright, so what we have on the left hand side, I put here, I have magnesium plus with 2 silver ion. Alright, arrow, what we have on the right hand side, so we have magnesium ion plus with 2 silver atoms. So this is the answer for the ionic overall ionic equation. So now we try to do the cell notation. All right, so how to do the cell notation? So we do 2 line here. All right, so here one line. All right, so next we check the half equation at anode. So we check the half equation at anode. Magnesium, all right, become magnesium ion by losing 2 electron. All right, take the magnesium, put here, and put the physical state of magnesium solid. So here we put magnesium ion, it will ionize in the aqueous solution. So we put aqueous solution. If here concentration is not given, so no need to write the concentration. Right, so in this question concentration is not given. All right, so we go for half equation at cathode. Half equation at cathode, silver ion gain 1 electron and form silver atom. All right, so this exists as aqueous, so we put aqueous. Then we take the silver atom, we put here exists as solid. So this is the cell notation that student should write. All right, so this is the question that student must practice. So please practice. I already answered all the question, and we will move on to the next essay question. Please check this essay question. I already discussed in the previous video also, so I discuss again. All right, you are given apparatus material like lemon. Sometime they will give potato. All right, so copper nail, zinc nail. Please remember zinc nail is more electropositive. Crocodile clip, connecting wire, LED bulb. All right, so we need to draw a diagram to construct a simple voltaic cell using the above material and write down the procedure, half equation for oxidation, half equation for reduction, and half observation, and calculate the voltage produced. The E naught value is given. All right, so the diagram we draw like this. All right, so the diagram is drawn like this. So before that, how to do the procedure? So we check the procedure. All right, so I check the procedure. Clean copper nail and zinc nail by using sandpaper. Connect the copper nail and zinc nail to LED bulb using crocodile clip and connecting wire. Insert the copper nail and zinc nail into the lemon. All right, so observe and record the changes occur to the LED bulb. So observation, so I write down the observation. So here they ask the observation. The LED bulb will lights up. Alright, so here zinc nail is more electropositive, so zinc nail will act as negative terminal. Alright, so this is positive terminal, so the electron will flow from the zinc nail to the copper nail, so then it will be released. So zinc nail undergo oxidation, so at negative terminal zinc undergo oxidation from zinc to positive and loses 2 electron. The electron will be gained. Plus, please remember electron is negative charge, so will be gained. Copper nail will not gain electron, so take from something from here. So this is a lemon. Lemon contains citric acid. Citric acid contains hydrogen ion. All right, so the negative charges will be attracted to the hydrogen ion. So positive terminal. So how to do the half equation? Put 2 hydrogen ion, gain 2 electron and form hydrogen gas. All right, so this is the half equation. So explanation that student need to do here. All right, so please remember zinc nail is more electropositive than copper nail. This is because the E naught value of zinc is more negative than the E naught value of copper. Okay, thus zinc act as anode. All right, so zinc act as negative terminal. We can put negative terminal. Copper can act as positive terminal. All right, so zinc atoms from the zinc nail undergo oxidation. So half equation written here. The electron that released from the released by the zinc nail will move to the copper nail, and the lemon contains citric acid, and the hydrogen ion from the lemon will undergo reduction. So half equation is written here. All right, so how to do the how to calculate the voltage? Please remember the formula: E naught value of cathode minus with E naught value of anode. So E naught value of cathode. All right, so please put your cathode. All right, so the E naught value that we will get is 0.00 volt. All right, so the E naught value here will be negative 0.76. So apply in the formula, so we will get 0.76. So please remember, oxidizing agent undergo reduction. So we put here redox. So we cancel OX. Which one undergo reduction? So answer hydrogen ion. So I put here redox, cancel the RED. Which one undergo oxidation will be zinc atom. So this question, please go through and please do more revision. All right, we move on to the next question. All right, we move on to the next question. Look at this question. So this is under electroplating, can come out for the essay question. All right, so one Ronnie bought a dozen of iron spoon from a supermarket. She found some of the spoon has been rusted. Based on the knowledge of electroplating, they already put here electroplating. Describe an experiment to carry out in the laboratory to electroplate the iron spoon. In your description must include the name of the electroplating metal. All right, so material, apparatus, procedure, observation at anode, observation at cathode, half equation at anode and cathode. So here 10 marks is given. So how to answer? We can take the iron spoon. All right, iron spoon can be coated with what? Coated with copper strip. All right, so this copper strip should be placed at anode. So this is example of electrolytic cell, and the object should be placed at cathode. All right, so please remember this one. So I take copper electrode. Name of the electroplating metal will be copper. We can take silver also. Beaker, connecting wire, battery, rheostat, and switch. All right, so how to draw this experiment setup? If let's say they ask you us to draw, please draw like this. So here I put copper strip. All right, so here iron spoon. All right, so then we have a battery here. All right, so we have switch. All right, please make sure put rheostat. All right, so put here, and please make sure dip the iron spoon completely in the solution. So this solution, so the solution electrolyte that we should take, we must remember the electrolyte here, the electrode is copper electrode. So or we put copper strip. So the electrolyte must contain copper 2 ion. So the suitable electrolyte will be copper 2 sulfate solution. All right, so please put here, this is iron spoon. All right, so please make sure put your rheostat is very important. We must use low current here. All right, so battery, all please label. So and please remember the safety precaution method, we must use low current. The iron spoon must spin slowly throughout the experiment. All right, and copper plate and copper 2 sulfate solution, iron spoon, and sandpaper is the material. So for this question, no need to draw. All right, so procedure, iron spoon is cleaned with sandpaper, and 200 cm power 3 of 0.5 mole dm negative 3 of copper 2 sulfate solution is measured and poured into a beaker. So when we have 200 cm power 3, add one more apparatus here, measuring cylinder. All right, so we need to measure the solution, so measuring cylinder. All right, next one, a copper plate and iron spoon are connected to the positive and negative terminal. Please put this word respectively. All right, so both copper plate and iron spoon connected to the battery, switch, and rheostat using connecting wire. Both electrode are immersed into a beaker containing copper 2 sulfate solution. The switch is turned on, and the changes that occur is observed and recorded. All right, so please remember here the plate is used copper is active. All right, so active, the factor that involved in this reaction will be factor 3. So factor 3 is known as type of electrode. All right, type of electrode. So at anode, which is positive terminal. So electrode active. So please take the copper from the electrode. It will ionize or oxidize to form copper 2 ion by losing 2 electron. All right, so next cathode. Cathode, please check from the solution. Copper 2 sulfate solution. Copper 2 sulfate solution contain copper 2 ion, sulfate ion, hydrogen ion, and hydroxide ion. Copper cathode undergo reduction, so it will gain electron. The charge of electron is negative. All right, so negative repel. Okay, remove these 2 ion and check the E naught value of copper 2 ion is positive 0.34, and this one the E naught value is 0.00. So please remember, cathode always choose the E naught value higher. So which one will be chosen to be discharged will be copper 2 ion. So cathode copper 2 ion gain 2 electron and form copper metal, and this brown color solid. So please check the observation at anode. So they ask observation, please check the requirement of the question. Observation at cathode and anode. So I put here, I use table. So observation at anode, copper plate, copper metal corrodes and become thinner, or we no need to put corrode, just put thinner enough. All right, so no need to use corrode, copper metal or copper strip become thinner. All right, next one, deposition of tin. and uniform layer of brown solid on the surface of iron sponge. Please write like this. All right, so next one, the half equation already given here. So this experiment also very important for SPM. Please remember electroplating. Please do revision and do. All right, we move on to the next question. We move on to the last essay question. So please check this question. All right, a student carry out an experiment to study one of the factor affecting the electrolysis process. So please remember we have three factor: factor 1, factor 2, factor 3. Factor 1 is our standard electrode potential value series. All right, so standard electrode potential value series. All right, second factor will be, please remember, concentration factor, and third factor, please remember, type of electrode. So we check the observation given at the cathode and anode at the set 1. So set 1 cathode is given colorless gas bubbles is released. So when cathode colorless gas bubble is given, so this is known as negative terminal. Anode is a positive terminal. So when colorless gas bubbles is given off at cathode, so this will be hydrogen gas. All right. So anode, please remember, greenish yellow gas bubbles is released. So this gas will be chlorine gas. All right. So here the cathode colorless gas bubbles is given off, so this is hydrogen gas. Here colorless gas bubble is given off at anode colorless gas bubble is oxygen gas. All right, so please remember this type of observation. All right, so we try to do the check the equation question. So by using suitable electrolyte, describe an experiment. They want us to describe an experiment to be carried out and to obtain the observation. All right, so explain why there's a differences in the observation. The E naught value is given and the equation also is given. I do the similar question that contains in the module. All right, that I put in the module. All right, so check this question. This question is the similar question just now we read. So for the question, so we check to investigate the effects of concentration of ion and ion chosen selectively to be discharged at anode. A student carry out the experiment to study the factor affecting the concentration of electrolyte. Both experiment use carbon electrode. Carbon is inert electrode. Please remember, using suitable electrolyte, describe an experiment. All right, so we need to include material, apparatus, procedure, observation, product, form at anode, half equation at cathode, anode. All right, so observation. So here half equation at anode. All right, so how to do this experiment? So we try to draw, we need the electrolytic cell. So we need the electrolytic cell. So I draw the electrolytic cell. All right, so no need to draw the experiment setup in the question. So they never ask. So just draw, all right, sketch the apparatus setup to get the material and apparatus. So we need switch here. All right, so this is the experiment setup. So the carbon electrode is here. All right, so anode, the gas is collected. So we put anode is very important. So we put a test tube at anode. If want to put at cathode also can. All right, so this is the experiment setup that students should write. All right, so the suitable electrolyte that I want to take here. All right, so I take 0.0011 mole dm negative 3 of sodium chloride. All right, so sodium chloride. All right, so the factor, investigate the concentration factor. All right, so when this experiment is conducted by using dilute sodium chloride solution, the sodium chloride solution, all right, so please remember it contains sodium ion, chloride ion, hydrogen ion, and hydroxide ion. All right, so anode, I move the ion at anode, so anode and cathode. So anode will be positive terminal, cathode will be negative terminal, hydroxide ion and chloride ion. So here will be sodium ion and hydrogen ion. This is positive 1.36, so this will be positive 0.34 or 40, sorry. So which anode always choose the E naught value lower, so this ion will be chosen. All right, if dilute, all right, please remember if dilute. So this is under factor 1. All right, so factor 1 we should use the E naught value. Cathode always choose the E naught value higher. So E naught value, this is 0.00, and E naught value of sodium ion. Right, E naught value of sodium ion, please remember negative 2.71. Always choose the E naught value higher. So that means cathode, okay, we will get hydrogen ion. So how to do half equation at anode? So hydroxide ion put 4 orang utan. Alright, so they makan 2 biji orange and to minum 2 gelas air and makan 4 biji apple. So we go for cathode. How to do half equation at cathode? Hydrogen ion put 2 in front, gain 2 electron and form hydrogen gas. So this is for set 1. Alright, so please remember for set 1. Right, let's say the set 2. Set 2 they use concentrated. concentrated sodium chloride, or they use 1.0 mole Dm negative 3 sodium chloride solution. And please remember, this will be under factor 2. Factor 2 should be concentrated. Two terms that student must remember: it should be concentrated, all right, and also should have allied ions. All right, so when this we have allied ions, so please move anode, all right, positive terminal, cathode, negative terminal. Please move the ion to anode and cathode. So anode chloride ion and hydroxide ion will be attracted to anode. Okay, here's sodium ion and hydrogen ion. Sorry, cathode, the factor always factor 1, always choose the E naught value higher, so hydrogen ion. All right, so when we have concentrated and there is allied ion. Allied ion is chloride ion. So always choose allied ion. Why? Because the number of chloride ion per unit volume is higher, or the concentration of chloride ion is higher than hydroxide ion. So, and not how to do half equation. So we put chloride ion, please put 2 here. Alright, so become chlorine molecule by losing 2 electron or donate 2 electrons. So I put here chlorine molecule. So we will get greenish yellow gas bubbles will release. All right, so cathode, always remember we choose hydrogen ion, so please put 2 also, gain 2 electron and form hydrogen gas. So how to answer this question, we check the module. So first thing, we need to list out all the materials. So 1.0 mole Dm negative 3 of sodium chloride solution, 0.001 mole Dm negative 3 of sodium chloride solution. All right, litmus paper to test the chlorine gas. All right, and wooden splinter to test the colorless gas bubbles given off at anode. All right, battery, carbon electrode, electrolytic cell, connecting wire, crocodile clip, ammeter, test tube, and switch. Alright, so we measure and pour 0.001 mole Dm negative 3 of sodium chloride solution into the electrolytic cell, more than half full. Invert test tube filled with 0.0001 mole Dm negative 3 of sodium chloride solution at anode of carbon electrode. Alright, so next connect the carbon electrodes to battery, switch, ammeter, okay, using connecting wire and crocodile clip. Turn on the switch to complete the circuit. Collect the gas release at anode, observe and record the observation, and we need to test also. Please remember to put test, collect and test. Alright, so next one, repeat the step 1 until step 6 using 1.0 mole Dm negative 3 of sodium chloride solution to replace 0.0001 mole Dm negative 3 of sodium chloride solution. Alright, next we go for observation. They want the observation at and product form at anode and cathode. So observation at anode. So anode will be positive terminal. So here greenish yellow gas bubbles. So we need to describe test here. Okay, greenish yellow gas bubbles with pungent and choking smell is released. This gas turns moist blue litmus paper to the red and then bleach. Make sure put bleach. Alright, so chlorine molecules is the product that form at anode. Alright, so cathode. So we check the cathode. Cathode will be oxygen molecule. So here chlorine molecule. So observation at cathode must come with anode must come with test also. So colorless gas bubbles which relights glowing wooden splinter is produced or released. All right, so and half equation at anode. So I already do just now. So we do like this: half equation at anode for set 1 and set 2. Explanation. How to explain? So I already do the explanation here. Chloride ion and hydroxide ion. Please remember anode. Alright, positive terminal. So we will have chloride ion and hydroxide ion are attracted. Please write down the first point. Chloride ions and hydroxide ion are attracted to anode. Chloride ion are selectively chosen to be discharged at anode. Why? Because this is concentrated. Because the concentration of chloride ion is higher than hydroxide ion. Or we can put the number of chloride ions. Then we put per unit volume. Volume is higher than hydroxide ion. So any answer? All right, so here we already explained. So next we go for set 2, 0.001 1 mole Dm negative 3 of sodium chloride solution. All right, so the half equation is given. So we explain. So chloride ion and hydroxide ion are attracted to anode. Hydroxide ion are selectively chosen to be discharged at anode. Why? Because the E naught value. Please remember the E naught value. All right, E naught value of hydroxide ion positive 0.40, and the E naught value of chloride ion will be positive 1.36. So please remember, so E naught value of hydroxide ion is less positive than the E naught value of chloride ion. So therefore chloride hydroxide ion will be selectively chosen to be discharged. So this experiment is very, very important for SPM chemistry paper. So that's all from chapter 1 redox equilibrium. I hope student will understand, will do more questions. So that's all from me. Okay, we will meet up in next slot. Take care. Bye bye. See y'all.